Good afternoon, pilot teachers, and good afternoon, students.
Good afternoon, Mrs. Jericho.
Thank you. Sit down. Okay, today's lesson is on circles, which is a subtopic of geometry. And from the last lesson, you were told to write some definitions of terms associated with a circle. We are going to check on those definitions now. Okay? I'm going to ask one of you to define first what a circle is. What is a circle? This boy in front here. Can you get the mic? Tell us what a circle is. Come on, he doesn't know. Next one.
A shape with only one side.
A shape with only one side. That is not right. Next one, pass it on. He'll try that. What is a circle?
A circle is a curve consisting of all the points at a constant distance. The radius from a fixed point, the center.
Good. It is made up of a set of points which are equidistant from the center. Equidistant meaning they are the same distance from the center. Okay, on this chart I have the definitions, and you look at first the circle to check that you have that in. Alright, so that's the circle, the set of all points that are fixed distance from a point called the center or the origin. Next one, diameter. Tell me what the diameter is.
A chord of a circle that passes through the center of the circle. The length of the diameter of a circle is twice the length of the radius of the circle.
Okay, the diameter is simply a line drawn from one end of the circumference passing through the center to the opposite end of the circumference. Okay, so here is a circle that I have here. This is a circle. I've drawn two circles for you. This is one of them. The diameter is drawn from the one end of the circumference. It has to pass through the center and to the opposite end of the circumference. So, right, that's what the diameter is. Next one, we have the radius. Pass it on. What's the radius?
The radius is the distance from the center of a circle to any point on its circumference.
Okay, good. From the center to any point on the circumference. From the center to any point on the circumference, that's the radius. Okay, that will be the diameter. All right? Next one, arc. What is an arc of a circle?
Part of the circumference of a circle.
Part of the circumference of a circle. So any part of this circumference is called the arc. Right, next one, chord.
A chord is a line joining 2 points on a circumference. The diameter is the longest chord.
Good. Any line joining 2 points on the circumference. So here I can draw a chord there. All right, next one, segment. A segment of a circle.
A region of a circle bounded by an arc and a chord.
A region in a circle bounded by an arc and a circle. The chord divides the circle into 2 segments. Okay, here I drew a chord earlier on. This is called the minor segment, the smaller part of the circle, and this is called the major segment. So the chord divides the circle into 2 segments. The smaller one, the minor segment, and the bigger one, the major segment. Next one, sector. What is a sector of a circle?
A region of a circle bounded by an arc and 2 radii.
Okay, the sector is formed by 2 radii bounded by an arc. Here, 2 radii, one from there, one to that opposite end. This shaded area is called the sector. And this is the minor sector. The big one is the major sector. All right, last one, tangent.
A tangent is a line which touches a circle at one point. This point is called the point of tangency.
Tangency, yes. So, the tangent touches the circle at one point. All right, that will be a tangent. Okay, so those are the parts of the circle. You learned about them earlier on in your earlier school years. We just basically went through those quickly. Our lesson today is on the angle properties here, angle properties of a circle. There are basically 4 properties. 1, 2, and 3 and 4 there. So I'm going to go through each of those properties. All right, property 1 here. The angle which an arc of a circle subtends at the center is twice the angle which the arc subtends at the circumference. So in this property, we are talking about 2 angles that one arc subtends. One at the center, so this is the arc. You watching? That's the arc. That's the first angle that the arc subtends. That's the angle at the center. And there is the other angle that this arc subtends at the circumference there. Now the property about these 2 angles is that this angle at the center is twice the angle at the circumference. So if this angle is marked A, the size of this will be 2A. If this angle is 60 degrees, this angle there will be 120. If this is 150 degrees, what will this angle be? 75 degrees. Okay, so that's property 1. But it's got to be the same arc that subtends those 2 angles. All right? That's property 1. Okay, property 2 to do with this diagram here. And, sorry, we go back to these 2 diagrams. It also shows in there where the arc is. So let's get back there. This is the arc there. This arc subtends this angle at the center, and it also subtends this angle at the circumference. So this angle is half this angle, and this angle is twice that angle, right? And the third diagram here, This is the arc. Okay, it subtends this angle at the center marked O, and this same arc also subtends that angle at the circumference. So this angle will be half that angle there, and this angle at the center is twice that angle. Okay, so those are three cases there on the first property. The second one, if a triangle is inscribed in a circle, the angle at the circumference is a right angle. Now, that means the base of the triangle must be the diameter. Only if the base is the diameter, then this angle at the circumference will be a right angle. I remember that is being taught in grade 10, so you should remember that also. Right? If this is the diameter, you join these 2 points at the circumference, this angle is a right angle, measuring 90 degrees. See that now? Okay. Property 3, angles in the same segment are equal. They must be subtended by the same arc. Okay, remember, when you draw a chord, it divides the circle into 2 segments. All right. That property is shown on this diagram. The chord is AB. See the chord AB? Angle APB, which is this one, and angle AQB, which is that one, end up in the same segment. And because they are in the same segment, these 2 angles are said to be equal. You can prove that by taking a protractor and actually drawing a circle and measuring those 2 angles. Mathematicians have already proved this. All right? So, these 2 angles are equal. They are in the same segment and they are subtended by the same arc. Here is the arc. That's the chord dividing the circle into 2 segments. These 2 angles end up in the same segment and they are subtended by the same arc. Understand? Property 3. All right, property 4 here. Property 4 here. This is a quadrilateral inscribed in a circle. This quadrilateral is called a cyclic quadrilateral. Okay? Cyclic quadrilateral inscribed in a circle. The property about cyclic quadrilaterals and their angles is that the opposite angles of any quadrilateral inscribed in a circle are supplementary. What does supplementary mean? They add up to 180 degrees. Yes, good. Okay, that means that B plus D equals 180, and A plus C is also equal to 180. So these are the 4 properties you need to know in order to do the exercise that's there in front of you. Okay, there's question 1 up there on the screen. Yeah, question 1 is here. In the figure below, if angle AOB, which is this angle here, if angle AOB is 76 degrees, we have to find angle ACB. So it's this angle here. You have, what property has got to do with this question? Property 1, right? Same arc subtends the two angles, one at the center and one at the circumference. So if this angle is 76 degrees, what's the angle ACB, or the size of angle ACB? 38 degrees. Okay. I give you 2 minutes to do question 2. If you finish that question, you carry on to question 3. You have the worksheets there. Okay. What's the answer to question 2?
120 degrees.
120 degrees, you agree? All right, let me just check that for those who didn't quite find that. We are supposed to find BOC. BOC is that angle there. This angle at the circumference, that angle, knowing that it is an equilateral triangle, or the angles of an equilateral triangle are 60 degrees, right? So that will be 60 degrees there. This angle is the angle subtended by the same arc. So it will be 120, and all those three angles are the same. So angle BOC is going to be also 120 degrees. Okay, question 3 next. CDC? Question 3. Right, I think we are ready for answer to question 3. Who's going to give us the answer to question 3, which is this one here? That angle is 116. We have to find angle A, B, C.
Angle ABC equals 61 degrees.
Good. Angle ABC is 61 degrees. How do we know? You have to find this angle first to get to that angle. Okay. This angle ACB is half of 116, which is 58. Now we are told that this is an isosceles triangle, so AC is equal to CB. Therefore, these two angles will be the same. So it will be 180, take away 58, and divide your answer by 2. That's how you get 61 degrees. Okay, next question 4. This time it's not property 1, it will be property 3, angles in the same segment. So what's the property about angles in the same segment? We finished? Angles in the same segment. How do we know they are in the same segment? You have to indicate where the chord is first. Now, this is where the chord is drawn. So on your diagram, you draw the chord to find out whether the two angles are in the same segment. You draw the chord from there to there, and you'll find that these two angles end up in the same segment. So if this is 50, what will X be?
50 degrees.
50 degrees, correct. Okay. Number 5. Okay, I'm going to ask the next question. We are going to start going through question 5. This question has got to do with which property? Property 4. It is a cyclic quadrilateral. Okay? If angle B is 105, what will angle D be? What will angle D be?
Angle D is equals to 75 degrees.
That's good. Yes, 75 degrees. You subtract 105 from 180. Okay, next one. What will be the value of angle C?
Angle C is equals to 110 degrees.
All right, that's correct. Good. So we use property 4 to answer question 5. Opposite angles in a cyclic quadrilateral are supplementary. Next one, question 6. We finish question 6? Okay. What will be the value of y?
Y is equals to 58 degrees.
Agree? I'd agree with that. You draw the chord here. Angle y and 58 degrees end up in the same segment. So y will be equal to 58. Now what will the value of x be?
X is 27 degrees.
Okay, good. 27 degrees. This time you draw the chord here on this end. And it tells you that these two angles end up in the same segment. So the important thing, you have to draw the chord first. Find out whether the two angles marked are in the same segment. Then they will be equal if they are in the same segment. Okay, next question, 7. Who's yet to finish question 7? Yet to finish? Nobody. So let's go through that one. Number 7. Cyclic quadrilateral again. So you would be looking at property 4. Okay, property 4 there. What's the value of angle X?
83 degrees.
83 degrees, that is correct. And what's the value of angle Y?
70 degrees.
All right, who didn't get those two values right? Good. Let's go on to the next one. Question 8. Question 8 is an easy one, right? It has to do with property 2. So, where is the right angle? Where is the right angle? The right angle is angle ACB or BCA. All right, so we are going to use Pythagoras Theorem first. What's the answer to the length of AC, Jake?
9.75 centimeters.
9.75. Now, is that exact? It is to 2 decimal places. Sometimes the question will ask you to write your answer using an exact value in exact form. If the question says write the answer in exact form, then it's going to be what? What will the answer be? If it says write the answer in exact form, what are you going to tell me? Root 95. The exact value of AC is root 95. To 2 decimal places is 9.75. So you have to show or indicate your degree of accuracy. In bracket, you have to write to 2 decimal places. All right? Question 9. In question 9, what's the value of A? Next, question 9. What's the value of A?
32 degrees.
32 degrees is correct, yes. And what's the value of B?
42 degrees.
42 degrees. Good. Okay, question 10. Question 10 there. And question 10 here. ABCD is also a cyclic quadrilateral. All right? You agree with what I'm saying? Okay, so angle A there is 70 degrees. This angle C is opposite to angle A. So what's the value of angle C?
10 degrees.
110
10
degrees. We agree with that. That's X, marked X. So X equals 110. All right, if X equals 110, Y equals?
Y equals 20.
Y equals 20 degrees. That's correct. All right, and question 11, last one. That is to do with property 2, easy to find there. What will be the answer to the diameter of that circle?
5.83 centimeters.
Okay, good. Good afternoon, pilot teachers, and good afternoon, students. And pilot teachers, don't forget the keyword for today is circles 2.